Hello, everybody. We're going to be looking at a statistical concept called resampling. And in this particular case, I'm going to look at a data set that you already know well. I'm presuming that you're in a well-formatted R project. And I would like you to go to the Moodle page and go grab the city race data set if you don't have it already, and put it in this project folder so that when you click on files, you see that dude over there. Now, we've played with this guy before. I'm going to load him in. I'm going to load ggplot. Let's pull up a plot. This shows me the distribution of races inside the data set, and I'm going to build a few tables. Now, what we're going to presume for the next 5-10 minutes of this video is that this 20,000 person collection is the entire population of people we're interested in. And it would be unfeasible or infeasible for me in real life to go get 20,000 people and literally record down their race, or really record any sort of defining feature about those people. You can't do that. So what we do instead is we sample. Now, R is designed to do statistics, and sampling is at the root of statistics. So it has a beautiful command. I'm going to call my sample, and I'm going to sample from the city race data set, the race column. Let's take a peek here real quick. The city race data set only has the race column. It just records white, black, white, black, white, 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 whatever. Right? So it just records the races of the individuals. And then say I'm going to pull 100 people. Okay, so I do that. I now have a vector or an array of 100 races, black, black, white, white. So it's just a random collection from the 20,000 I had before, but it's only 100 long. Well, let's streamline this a little more. I want n to be 100, that is my sample size. And then I'm going to pull n of those. And now let's actually measure the proportion of, say, black people that are in my particular sample. So I could do a proportion table, table of my sample. And it will do that for me. So the first one I got was 29%. Let's resample. Rebuild the proportion table. Now I got 26%. Resample, rebuild my proportion table. Now I got 18%. And just owing to the fact that we're doing this one random sampling, every time I sample, I will get a slightly different proportion. So the question is, how do those proportions line up? Can I use the fact that there's variability in my resampling to actually learn something about the overall population? Now, the overall population here has 27.265% black. We're going to record that here. Okay, and now we're going to presume that we don't know that, right? Because in reality, we would never have the entire population. I'm going to see if I can use sampling to learn that piece of information about the data set. So next thing, I want to streamline this computation. Let's say I want the proportion of blacks, and I'm going to do a couple of kind of silly things here. I'm going to say my sample equals black. Now I'm doing this in the command line because I just want to see what this command does. So first of all, that just gives me a bunch of trues and falses. So that's yes, the person's black versus no, the person's not. Okay, in the command line again, if I take the sum of a bunch of trues and falses, that'll give me the number of trues. So in this particular sample, I had 18 black people. Then if I divide by the sample size, that'll give me my proportion. So it looks like right there, copy, paste, I have a way to measure the number of black people that are in my particular proportion. So, or my particular sample. So I take my sample, I get my proportion. Here, let's have that print. Take my sample, get my proportion. Take my sample, get my proportion. Now this is the same thing as what was happening within the proportion table. It's maybe just a little more streamlined. Now, it's entirely silly of me to come back here and do over and over and over again, run the sample and then the proportion tester over and over again. I want to have a piece of code that does that for me. So sidestep. Let's talk about for loops. A for loop is kind of one of the fundamental things in computer science that you need to be able to do in any programming language. So a for loop is just meant to do repetitive tasks for you. Right? So, and the anatomy of it's fairly simple. We say for. We give it a counter, like I'm going to say j in 1 colon, let's say 10. And just follow me for a second on this. If I do curly brackets, and then inside my curly brackets, I'm just going to do something simple like print j to the second. Now, what this is going to do is it's going to take the letter or the index j and say, okay, when index j is 1, I'm going to print 1 to the second. Then I reach the curly bracket, I'm going to take index j and make it 2, print 2 to the second. Then I'm going to come back up here, make it 3, print 3 to the second, and so on. And I run it, and there I go. 1 to the second, 2 to the second, 3 to the second, 4 to the second, so on. This is a really simple kind of dumb for loop, but it shows you, hopefully, that a for loop is designed to do one task or a collection of small tasks many, many times. So I could do this 100 times, and I get all the way up to 100 squared. So let's come back here, and I'm going to wrap this guy in a for loop. So I'm going to say for j in 1, 2. I want to take like 10,000 different resamplings. And then I'm going to take my code here, copy, paste. I don't want it to print 10,000 times. I'm going to take my parentheses off. And I'm going to do one more thing. So if I were to run this, it's just going to say, build me a sample of size 100, calculate the proportion of blacks. Build me another sample of size 100, build me the proportion of blacks. It's going to do that 10,000 times. I want to keep track of those proportions. So I'm going to start off with an empty list of proportions. And then for every step through the loop, I'm just going to store it. So let's see what this does. There's the empty list. It says it's empty. There's nothing there. And we wait for a couple of seconds. Okay, it just did 10,000 resamplings from my population. And the first sampling had 25% blacks. Next sampling had 24%. The next sampling had 20%. The next sample had 36%. Now we get a chance to see how these proportions actually line up. So let's make a histogram. So I'm going to make a ggplot. All right, and in my aesthetic, I'm just going to say, let's take the proportion of blacks in my histogram. Let's take the bin width to be something like 0.2. We'll take the color to be black. That's the outline color. And we'll take the fill to be, this is my personal favorite. I think it's kind of the most aesthetically pleasing. Oh, 0.2 is way too big. 0.02. Let's see what happens. Okay, there we go. Oh, I want to do one more thing. Sorry. Plus, I'm going to make this go from 0 to 1 because these are proportions. And there I am. Okay, so I've got from 0% to 100%. I took 10,000 samples of size 100 from my population, and I did not get the same proportion the same time over and over and over again. I got a distribution of proportions. And beautifully enough, this distribution looks to be kind of like it's a normal distribution because it's actually a binomial distribution, but if you take enough samples, it is pretty close to normal. Now, if I were to change this and say, let's take my sample size to be 500, pause and think about what this might do. Is my distribution going to get skinnier or is my distribution going to get fatter? Pause and think. Okay, let's do it. So I'm going to build my empty list again, build 10,000 samples of size, so what did I do? I did size 500 and plot those dudes. Ooh, I got something skinnier. Well, let's think about that. If you sample more people, it's going to be harder to get really rare circumstances when there's like a really large proportion of Black people in the sample, or a very small people. Jeez, a small proportion of Black people in the population. Okay, so let's try again. What if I did 5,000 people in my sample? Now that's like a quarter of the population. That's humongous. That's technical. Okay, so we got to let it run for a second here. It's doing 10,000 samples of 5,000. Okay, it's done. There's my ggplot. Ooh, really skinny. I don't even really see that there's much of a difference there. If I make my bin width even smaller, Oh, I've got a couple of bins there. Let's go by something like really, really small. So it's this really tight, really skinny distribution. Still kind of looks like a normal distribution. Okay, let's go back. I have something like 0.02. What if I did the entire sample? Or I'm sorry, the entire population. Okay, let it run. So I'm just resampling everybody 10,000 times. Now stop and think. Am I going to get the same proportion of Black people in those populations every single time? Of course I do, because I sampled everybody. So in like the best case scenario, I would sample everybody, and then I would know exactly what the proportion is. And then why would I bother to do that 10,000 times? It doesn't make any sense. Right? But in the real world, it costs money to take samples. So if I take a sample of, say, size 100 again, all right, there's my size 100 sample. Boom, boom, there's 10,000 of them. And a ggplot of that, I actually get a distribution of samples. And that's where we're going to stop this video, and we're going to pick up from there in the next one.